architectures using graph theory.
Okay, great. Thank you for your introduction. As already said, I'm Jasmin and together with Frank, I wrote a paper about the pattern-based rewrite and refinement of architectures using graph theory. So to begin with, as we already heard, an application architecture represents the structure of the system. So its components, their relationships, and externally visible properties. But as I think you should all also know, there are many modeling languages and tools available. But most of the times, informal practice to represent architectures as graph structures is used. So when you start to model an architecture, you begin with an abstract level, for example, with two components which are connected, represented as a graph structure, and you add more and more details within time. So it's an iterative process. And during this process, you might face some problems you have to solve. And patterns can help you to solve those problems, since they document proven solutions for recurrent problems. Or maybe if you're already familiar with pattern languages, you might remember a specific pattern you want to apply. But then when you take a look at those patterns, as already said, they are text documents and they are documented in an abstract and readable manner. And as we can see here, this is an excerpt of the message-oriented middleware of the cloud computing patterns. And it's, I think overall it's 4 pages of text. So you can see that we have a context, we have a solution, we have a result, we have variations, and we also have related patterns. That's another information we use within our approach, because multiple related patterns are captured as a pattern language, and they form a network of patterns. You can see it with the related ones, and one single part of this network of patterns forms a so-called solution path, which we will use later on. But now the question is, how do we realize such a pattern within our architecture? And first of all, of course, if you want to solve a problem, you have to find the right or the suitable pattern. And then you have to read the document, you have to understand it, you have to adapt it to your use case, and then you have to realize it manually. So you can say that the consideration of patterns during the manual modeling of architectures requires a deep technical knowledge. And further, it results in multiple, possibly wrong realizations of each pattern. So since the manual modeling of architecture is already an error-prone and time-consuming task, the goal of our approach is to combine this process with an automated application of patterns. That's our pattern-based rewrite and refinement of architectures using those common informal proceeding to represent them as graph structures. And I want to start with an application example. So as you can see here, we have the input of our approach, and on the left-hand side we see an architectural graph consisting of 2 nodes. And we use colored graphs, so this node is of type client and the second node is of type server, and they are connected to each other. And the second input, or the second part of the input, is solution path. In this case, we have 2 patterns to be applied to the architectural graph. And the first pattern is the message-oriented middleware, the second one, the watchdog. You can also use just single patterns. So this is the input for our approach. And then in the first step, we want to apply the message-oriented middleware pattern, because the solution path defines the application order of within our approach. So for that, we have to check if the requirements are fulfilled. So for message-oriented middleware, we need to communicate with partners. Therefore, you can see that this requirement that we have communicating partners in this case a client and a server is fulfilled, so we can apply the pattern. And then in the next step, you can see that we have a modification fragment, which is just the node of type message-oriented middleware. And then this, so this fragment is called modification fragment. And then we have a local pattern operator, which is an algorithm which defines how to embed this fragment. And for that, we just remove this edge here and add those two other new edges, and we have also the new node. So for that, the message-oriented middleware pattern is applied to our architectural graph. And then in the next step, we want to apply the watchdog pattern. Therefore, only you monitor the server. So therefore, the required fragment is a node of type server. And then again, we have the modification fragment, which is right here. And with the local pattern operator, we add this node of type watchdog and connect it to the server. And this is the resulting modified architectural graph. So we added the message-oriented middleware pattern as well as the watchdog pattern. So this was a really simplistic application example, and now I want to show you the overall concept and a little teaser of the formalization. So again, we have the input shown up here. We have on the left-hand side the architectural graph with the components as nodes and the connectors as edges, which one point which is not depicted is that the components have assigned types. And the second part of our input is a specific solution path which you selected, which should be applied to our architectural graph, which is of a specific pattern language. And as already said, you might also use just single patterns. And then we have 3 steps. So we have an iterative approach. And within the first one, we select the pattern which should be applied in this step. So, as I already said, the solution path defines the application order. So in this case, we start with the first one, and each pattern consists of 3 parts. So we have the required fragment, the modification fragment, and the local pattern operator. And those 3 parts we will use in the next step. So the second step, the check requirement step, I've already seen that, just checks if the required fragment is a subgraph of our architectural graph. If it's a subgraph, the pattern can be applied to our architectural graph. If not, then not. So in this example, it's applicable because it's a subgraph. And then in the next step, we have our modification fragment and we have our local pattern operator shown up here. So in this step, we rewrite or refine our architecture and we embed this modification fragment into our architectural graph as seen down here. And therefore, the local pattern operator defines how it is embedded. So in this case, this node down here is replaced by the middle node, and the other nodes and edges are added as well. Then we have this modified architectural graph, which is then, of course, the basis for the next iteration, and so on. Okay, I think that's all from my side. Thank you so much for your attention, and I hope we have a few discussions at the poster session.
Thank you. We also left place for time for a question or two. I have one, you didn't go into the formalization.
No.
Do you use some kind of graph premise to specify things, or simply order replacements? Because you said you formalize things.
Yes.
This looks a little bit like a graph grammar.
Yes, we kind of used graph grammar. So we formalized the architectural graph and the solution path and everything, and also the required fragment and modification fragment. But for the local pattern operator, we just used algorithm. So, yeah.
Thank you again. circle also from the